Welcome back to another tutorial. We're going back to the basics because in this video we will design a 2020 aluminum extrusion. First we'll draw the profile, and this one is from Mizumi. And then I will show you how to use it in a quick and easy parameter-driven frame design. You could probably spend the extra time and configure and download each one from their website, but it's quicker to design them as needed. Looking at the drawing, we can see that it's 2020 with a slot opening of 6mm, a slot depth of 6, and an internal width of 12mm. We can see a flange width of 2mm, and it doesn't say it, but this is about 1.5, this diagonal flange. We can see a drill size for an M5 thread, which is 4.2, and an external radius of R1. It doesn't mention it, but the internal radius is around 0.25. So with all that information, we could get started with the extrusion drawing. Starting a sketch on the top plane, let's switch over to construction, pressing X and a center rectangle, and we will make this 20 by 20. I won't dimension both sides because I can just use the equal constraint. And then let's draw in a line and switch over to regular geometry and just draw approximately what the extrusion looks like. We will first use a mirror, and then we will use a circular pattern. When we're putting in that outer radius, making sure the two tangents are automatically added. If not, add them with the constraints. Because we're using just this construction line, we could half our dimensions. You could switch it to a center line and you can have an overall dimension, but whatever is easier for you. Next, let's open the fillet option and select all these points and then put in the dimension so they're all linked. With a mirror, let's mirror this over, excluding the corner radius. And now we can use that circular pattern around the origin with 4 instances and a circle of 4.2 to finish it off. So this is the extrusion. What I'll do is I will highlight everything and Control-C and copy it to my clipboard, and now we're ready to move on to a frame design. Starting a new design, let's open up the parameters under the Modify section and change parameters. We will set a parameter for the X, Y, and Z, so the width, depth, and height of the frame. We could do that by naming it and giving it a number. Selecting it, let's copy it so there are 5 of them. And this will be Y, Z, and then the X member, or the X extrusion, and the Y extrusion. The Y extrusion, because we will use a butt joint design, it will be X minus 2 times the extrusion, so 40. And the same thing with the Y, Y minus 40. So let's start a sketch on the top plane. So with the 2-pointed rectangle, swapping it to construction by pressing X, let's draw a box, the height of Y and the width of X. And we could either fix this in place with some points and horizontal and vertical to the origin, Or you could have drawn a center rectangle, or you could draw a two-pointed rectangle with some lines and use those lines as a midpoint to the origin. Whatever you want to do, I think this looks pretty clean. And we'll draw in with normal geometry some two-pointed rectangles to our extrusion size, so 20 by 20, and I'll just make these even, and we'll draw in the rest of them. We could mirror it, but I want to minimize the amount of times that I use the mirror, just for performance reasons. But we could select these and select one of the dimension lines and press equal. And let's extrude this symmetric and whole length to the length of Z. Let's now create a sketch on the right plane, and we will project the bodies that we just extruded. And let's turn them into construction, and again with the two-pointed rectangles. Now with the equal constraint, let's just equal these out so we don't have to add any dimensions. And let's extrude these symmetric whole length to a distance of xe, because these are the X members, or the X extrusions. And then finally the Y extrusions will be exactly the same. Just project everything and turn it into construction. You can press X to go into the line type construction mode, and then when you project it will automatically be construction, but work however you work. Next, with that two-pointed rectangle, we could place in where the extrusions will go. And these are the Y, so after symmetric and whole length, that will be YE for Y extrusions and new body. I'm not sure why it's doing this visual bug. I might need to restart my Fusion, but just press OK and it'll be fine. So that's the frame. It's quite simple. It's actually just a representation of the frame, but it is parametric. So if we go back into the parameters, we could change the shape. So 150, 150, and it will just update. Because it's a simplified shape, it's going to be the best performance. If we did the same thing with the extrusion profile, it'll be a little bit more laggy, but let's add those now. So let's start with the top. You can either do it from the origins and extrude either way, or just do it from the top. So we will project all of the extrusions, and now we can paste in the profile, and we'll just paste in 4 of them and constrain them in the corners. Use these arrows so you can move them in the plane that you're working in, because I do believe you can move this around in 3D space, and you don't want to do that. So if you drag from the center point, you're able to drag it around in 3D space. Not ideal. We will extrude the negative space. So let's select all of that. And you could either select this face to get yourself started, but what I prefer is in the extent type, the distance will be all. So if you change the frame, it will automatically update with the depth of the cut. So going back into the parameters, we will change the height. Let's say 400. We could see that the extrusion has been cut all the way through. Let's move on to the right plane and just let's hide these bodies and start a sketch on the end of the profiles. And again, pasting and constraining the extrusion profiles. One way you can quicken things up is just do one body and mirror it over. But visually that model won't make sense until the very end. In this way, you could go all the way back to the beginning and see a model of what it will actually look like, instead of individual extrusions that you would then have to mirror over. Remembering to cut all. And now the front plane. Now we can bring in the rest of the bodies. And now we have a completed parametric frame. We can verify this again by changing a parameter. And if you run into any lag, what you could do is go back before the extrusion cutouts and change the size of the frame here instead of after the extrusion cutouts, and it will perform a lot quicker. And now you can move to the end of your timeline and everything will automatically cut to the right size. So this is a classic butt joint, which means the height is the full length of the extrusion and the X and the Y extrusion are butt against it. One thing you'll need to consider with this frame design is you'll need a tool hole. So starting a sketch inside the slot, just do a 5mm hole and then press pull either to the other side, or since they're all going to be the same, what you do is you extend it to the other side and go into the objects to cut. And if you turn them all off, you can see the preview disappear. So we want to keep that one, and we want to keep that one. And it won't cut this extrusion because you want to keep the 4.2mm hole. And you can either add a thread or just remember to add the thread. And you don't want a full length. You would want maybe 8mm. You don't have to model it. You just have this little visual icon, little visual thread. And let's insert a screw just to show you what the joint looks like. It will be a hex button head screw. I'm pressing J to open up the mates, and you highlight the face, hold Control, and it will snap to the center. And the same thing here, hover over the face, press Control, and it will snap to the center. And bring this out 2 millimeters, or the thickness of this flange. And there you have a butt joint with a M5 screw. Let's hide that relationship and duplicate with joints to show how easy it is to add screws to other locations. So that's everything for this video. First we drew the 2020 profile sketch, and now we made it into a parametric frame design. It's quite simple. We can go back into the parameters and change them. And like I said, it's easier to make a visualization of the frame, which is fully parametric, and then going in and cutting out the extrusions. And then you could just go back here and change the frame, and it'll be easier to process. And then you could cut out the tool hole, and you will have space to drive the screw. If you had any questions or any suggestions, leave them in the comments below. Other than that, don't forget to like and subscribe, and I'll see you on the next video.